So you can see diazo coupling, which will give phenols. But this diazo coupling, if you see, if it is operated below 5 degrees centigrade, what would happen? And this structurally, this is how it is. N triple bond N plus. Okay. Now, if nitrogen takes away its lone pair, then this nitrogen will become NN with positive charge here. Okay. And if you see this nitrogen now, this has 6 electrons. Okay. So if it has 6 electrons, that means it can act like an electrophile. Okay. And this all has to be operated below 5 degrees centigrade. Okay. So when you do that, we take this and react that with phenol. And phenol, we know it is ortho-para directing. Okay. So from the para position, it will attack here. Correct. And to keep this reaction happening at a much faster rate, what do we take? I'll take mild OH minus, not very strong, mild OH minus. Mild OH minus matlab hai pH I have to maintain somewhere between somewhere between 8.5 to 9. Okay. So mild OH minus हमने डाल दिया. So on doing that, what do we make here now? So this is electrophilic aromatic substitution. So we will have N double bond N, and this group has connected with phenol here. So phenol got connected here. यहाँ पे ये group भी connect हो चुका है. So this group is ये N double bond N होता है, that is called azo group. Okay. So both sides there are some phenyl groups here, so that's why it is called azo colored dyes. So we have orange, red, sorry, orange dye. This is an orange color dye. Okay. Color happens, color is due to extended conjugation. Extended conjugation. From left side to right side, the conjugation will happen. So therefore, you will see orange dyes coming. Is that clear, beta? Right. This is called diazo coupling. See the examples and you know what are the conditions, important conditions we need to check out. One thing, pH N2 plus diazonium ion is a weak electrophile. It has been a weak electrophile and will normally attack highly reactive aromatic rings. What are the highly reactive aromatic rings? Like phenoxide ion, like phenol. Phenol is also highly activated, correct? Like aniline, right? NH2, right? These are the highly activated rings. So to give an example, suppose if I take phenol, I treat that with pH N2 plus. We just got a, with mild OH minus, we learned that we got an orange dye. And I gave you the structure above, so I'm not writing it again. So same way I can do it with pH NH2, which is aniline. If it reacts with pH N2 plus, okay, here mild H plus conditions are better. In the case of pH NH2, mild H plus conditions are better. This will also give a dye. Okay, it will also give a color dye. In fact, this would give a red color dye. And if you see by structure, this side benzene with N double bond N, and we have NH2. This is the molecule which is formed. Okay, this is the diazo product. If you react that with PHOCH3, anisole, okay, with PHNH2 plus, right? In this no reaction, this is mildly activating because OCH3 is not as strong activating acid of OH and NH2. So that's why it is mildly activating. Okay, to increase its reactivity, OCH3, what we can make, this diazonium salt which we got here, we can keep lot of nitro groups on it. So if at all I keep lot of nitro groups here, okay, then the reaction will take place. You'll have, because nitro groups will make that, you know, strongly withdrawing, so its electrophilicity will increase. So I'll N double bond L, then we have phenyl with OCH3. This is what is formed. Okay. So I hope that part is clear. So whenever you have to react, so we can say one important point here, that electron withdrawing groups of benzene, diazonium salt, diazonium ion increases its reactivity. So now for instance, if we have benzene with N2 plus for it, and I have some G group, and this G group could be OCH3, hydrogen, or NO2. Which one is strongly withdrawing? NO2 is strongly withdrawing, so reactive would be like that. That's how the reaction will take place. Is that clear, beta? Another important point which we can learn about that pH N2 plus, right? This cation exists in mild H plus or OH minus. Okay, but if strongly alkaline solution is taken, they convert into diazotic acid. So what is this diazotic acid? pH N triple bond N plus is there. Sorry, with strong base like OH minus, we'll have pH N double bond N OH. This is diazotic acid. It will convert into this. So we can't use very strong base. We can use strong acid, but the problem with the strong acid is it will deactivate the reactant like phenol or aniline. Usko deactivate kar dega. So it's always better to use it in mild acidic and mild basic conditions only. Okay. Now, next reaction in this is naphthalene. Okay. Naphthalene coupling. Sorry, naphthalene, naphthol. Naphthol coupling. The same reaction, just we are using, instead of benzene, we are using naphthol. What is naphthol? Naphthalene के ऊपर अगर अल्कोहल होगा तो उसको बोलते हैं naphthol. If you have OH present here, it is called alpha naphthol. Okay. If you have OH present on the next carbon here, this is called beta naphthol. Now let's see, if at all I take beta naphthol, and react that with pH N2 plus and Cl minus. Then what will be the product formed here? We'll have this as N and pH with OH. Because para position is completely occupied now. Now the azo group will form only at ortho position, and this is also a dye which is a red color. Okay. A red dye. It has a name, Sudan 1. The color's name is Sudan. See, the better way of remembering the colors, right? So formation of colors, formation of various colors. If you check out, if it is beta naphthol, it is red color. Okay, if it is phenol, okay, if it is phenol, it is orange color. Okay, so I'll write it as orange. Okay, if it is aniline, then it is yellow color. Correct. Remember it as ROY, ROY. So इधर कहीं रेड लिखा क्या? ऐसा लग रहा है मैंने कहीं रेड लिख दिया गलती से. Sorry, this is yellow. Okay, beta. So three reactions BPA, that is uh, beta naphthol, phenol, and aniline. BPA. Okay. So BPA ROY. So red, orange, yellow. So is that clear, beta? Right. So these are more like the name reactions, right? And next we'll see oxidation reactions in phenols. Major other reactions which are there are mostly oxidation reactions. So oxidation reactions of phenol. So first reaction being phenol, OH, and if you react that with KMNO4 और K2Cr2O7, ये हमने पहले कर चुके हैं. सब कुछ क्विनोन में बदल जाता है. इसका मैकेनिज्म का जरूरत नहीं है, जस्ट आपको पता होना चाहिए कि एवरीथिंग कन्वर्ट्स इनटू क्विनोन. Second, Lieberman nitroso reaction. JEE एडवांस के लिए काफी इंपॉर्टेंट रिएक्शन. After Riemer-Tiemann reaction, if I will bet anything for a high weightage, then this is the one. Lieberman nitroso reaction is one thing you should strongly check for the reaction. So if you take NaNO2 and with concentrated HCl, you remember what is happening with NaNO2. आपको फिर से मैं रिवर्स कर देता हूँ. NaNO2 plus HCl, ये सब as diazotization की reactions है. Form NaCl, HNO2. HNO2 का स्ट्रक्चर ऐसे रहेगा, N double bond O. In the presence of H plus, the lone pair will attack here, become H2O, N double bond O. This is a leaving group, so it will leave and make an electrophile. So this is an electrophile. Okay, so ये background आपको पता होना चाहिए हमेशा. So the minute it is given NaNO2, okay, the minute it is given NaNO2 in concentrated HCl, or directly sometimes it is given as HNO2. In HNO2 or concentrated HCl and NaNO2, it is the same thing. So NO plus is the electrophile. So electrophile will undergo EAS now. Electrophilic aromatic substitution हो जाएगा. And I'm doing at para position because I told you normally para is always the major product. So I got this. Now you can see that this will undergo tautomerization. टॉटमरिज्म होगा इसमें, और ये जो OH है ये वाला डबल बॉन्ड O बन जाएगा, यहाँ पे डबल बॉन्ड, यहाँ पे डबल बॉन्ड N, और OH इधर आ जाएगा. This has become more like oxime, correct? So this name is quinone monooxime. So phenol और oxime के बीच में tautomerism हो रहा है. Then if you react this with one more mole of phenol here, so one more mole of phenol here, all right? Then it would convert into O double bond here with this group which is present. Okay. And then we have double bond N, and that OH group is left. OH group is left and it is being replaced by this OH. Okay. So basically, ये OH है ना, this OH will be left out as OH2, and then phenol will attack on that. So you'll get this molecule, and once you get this, if you treat with NaOH, okay, on treatment of this NaOH, that H plus will be lost from that side. So we will have this as double bond O, double bond N, in with this O minus Na plus आ जाए. Okay. Now see the colors. Got it? Now this quinone, see every time we have oxime, oximes will be colored, and it has been found that this oxime is actually green color. The oxime is actually green color. Okay. Next, the next formation, this is called indophenol. Indophenol, and indophenol is actually red colored. Okay. So indophenol which is formed is actually red colored. Okay. And lastly, the color which is formed here is indophenol anion. Indophenol anion, and this will turn out to be blue color. Will turn out to be blue color, and that's how the colors are formed. Okay. Right. The better way of remembering here is GRB. आपको पता ना, आप जितने बुक्स है GRB publications के है, so remember it that way. Okay. All chemistry books come from majorly two publications: GRB publications and Balaji publications. So GRB publication मतलब याद हो जाना चाहिए कि ग्रीन से रेड कन्वर्ट होता है, रेड से ब्लू कन्वर्ट होता है. सिमरन ऐसा टेंशन मतलब कि सर इतना स्ट्रक्चर कैसे याद रहेगा? स्ट्रक्चर आपको कोई नहीं पूछेगा, इंडोफिनॉल का स्ट्रक्चर लिखो ना. आपको बेसिक आइडिया होना चाहिए कि लीबेनियम नाइट्रो रिएक्शन में फिनॉल्स ने नाइट्रो ग्रुप को लिया है, उसके बाद कलर चेंज होता है, और कलर चेंज किधर से होगा? ग्रीन से रेड, रेड से ब्लू. एंड दिस इज अ कंफर्मेटरी टेस्ट फॉर फिनॉल्स. ओके. So that is a second reaction. Let's see the next reaction. This is called Fry's rearrangement. Basically, Fry's rearrangement is, we already have, imagine, an acetyl or a acyl group here, and I'm reacting that with AlCl3 and heat. On doing that, we will get phenol, sorry, we'll get this as phenol OH here and C double bond O R at ortho position. I'll get the same phenol at para position, like this. These are the two products which are for ortho and para. Okay. Usually ortho is thermodynamically favored because you can see there is a stability, okay, because it is becoming more stable, and this is major product at around 160 degrees. मतलब हाई टेम्परेचर पे हमेशा ये मेजर होगा. This is kinetically favored product, okay, and that is major at 80 degrees or below. See the mechanism. So if you have C double bond O R here and AlCl3 is been there, which is an empty orbital. So the lone pair present here will attack the empty orbital, and you will get that as O double bond O R and AlCl3 minus and plus this. That you'll see as soon as that is formed, oxygen will take away its electrons and will form O AlCl3 minus and releasing C double bond O R plus. Okay, this is carbonyl group. Okay, so carbonyl carbocation, carbonyl carbocation is resonance stabilized and it is an electrophile. And since it is an electrophile, where does it attack? It can attack at both ortho and para positions. So that's why we would have this as oxygen क्या कर लेगा अपना electron फिर वापस ले लेगा. So we'll get this as O minus C double bond O R like this with H. Okay, and para पे आप देखोगे so we'll get this as O minus C double bond O R with like this with hydrogen here. अब ये बेस Cl माइनस जो है AlCl3 माइनस का, सो फ्रॉम द अदर मोल AlCl3 का जो Cl का पार्ट है लोन पेयर, that would accept hydrogen from here and remove that and get that to oxygen. So oxygen will take away as OH, retain the aromaticity, COR plus OH and COR, final products. So that's how these are the final products for beta. So that is about Fry's rearrangement, how it is happening. So these are the oxidation reactions. These three are oxidation reactions. Okay. Now let us see the important EAS reactions of phenol. EAS reactions of phenol. First one is bromination. So bromination में भी दो तरह के हैं. So we'll start with A kind, in which we take phenol, react that with Br2 in CS2 less than 5 degrees centigrade. Then how does the reaction proceed? We will get phenol with bromine substituted at ortho and bromine substituted at para. These are the major products we will get. And para is always major. If you see the mechanism now, phenol, as you react that with Br and Br here, correct? मैं para से explain करना चाहता हूँ. So you remove the Br here. It is acting like an electrophile. Br2 itself is acting like an electrophile. So we will get this lone pair is supporting here as a double bond. So we'll get this as positive here. और जैसे ही हो जाएगा ये डबल बॉन्ड्स इधर शिफ्ट हो जाएंगे. I'll get one Br and I'll have one hydrogen. So जो Br माइनस निकला ना, जो Br माइनस निकला वो इमेजिन करो यहाँ से H प्लस ले लेगा, करेक्ट. एरोमेटिसिटी फिर से रिटेन हो जाएगा. So we will get this as OH and Br plus HBr. ये HBr निकल गया. Is that clear, beta? The solvent which we can use can be CS2, CCl4, non-polar लेना है आपको. Only benzene, you can take it, but not very much used. These two are mostly used. Is that clear, beta? Right. So that is the bromination in non-polar. Okay. Now see the bromination in polar form. So if we take Br2 in H2O, okay, how does this happen? So we take phenol with OH, and when you react that with Br2 in H2O, we will get bromine at all the positions. I mean ortho and para positions. So it will behave so strongly. So let us see the mechanism. Firstly, beta, the pointers which we need to remember is that first Br2 reacts with H2O to give protonated hypobromous acid. Okay. And this acid will have more reactive Br plus present. Let me show you how. Br2 plus H2O, अब जैसे react करोगे, so we will have this as Br minus and Br plus with OH2 plus. ठीक है. अच्छा, कुछ बुक्स ऐसे भी दिखाएंगे, इसका मतलब सेम है. पहले HBr दिखाएंगे, फिर बोलेंगे कि HOBr बन रहा है. ठीक है, क्योंकि बेटा HBr स्ट्रॉन्ग एसिड है ना. दिस O will again take and it will make this only. So we would get this form here. Okay, so we'll get this form. Now in this you can see OH2 is a very easy leaving group. Because it is an easy leaving group, तो काफी ज़्यादा Br plus produce कर सकता है. And it is a strong electrophile now. Earlier, when we reacted here, it is directly reacting with bromine. Bromine without charge, Br2 है, सारे bonded है, then it is a very weak electrophile. But in this case, bromine has become a strong electrophile, as well as the availability is also increased. So hence, how does the reaction proceed now? Let's see. So with OH here, when you treat that with Br OH2 plus here, correct? So this will attack on this bromine here. We will get this as double bond OH, double bond positive this way, and Br gets connected. Now you keep this for several times, Br2 several times in water. So you will get bromine coming on all the positions, and finally we will be left out with 3 bromines at ortho, para and meta position. Sorry, ortho, para positions. Okay, beta. Now what are the simple type of questions that can be asked here? See, instead of directly giving Br to water, ये देखो trick. Br to water नहीं दिया मैंने, लेकिन एक कॉम प्रोपोर्शनेशन रिएक्शन दे दिया. KBr plus KBrO3 aqueous, ये दोनों aqueous solution. This is a कॉम प्रोपोर्शनेशन रिएक्शन ना. Actually इसका रिजल्ट बनता है Br2 ही. So Br2 plus water. So उसने directly Br2 नहीं दिया है. So he has given is that some salt reacting. So eventually it will happen the same thing, that you will have 3 bromines here. Alright. So bromine, bromine and bromine. Okay. It is called 2,4,6 tribromo phenol. Okay. This is usually white in color, white crystalline form. If you have OH and C double bond O, OH, and we react that with Br2 and H2O, then we'll get the product this way, OH and C double bond, sorry, OH and Br and Br with CO2 coming out. ये कैसे हो गया? CO पूरा CO ग्रुप ही निकल गया. Okay, you see how it is done. See, normally when you have OH here, first C double bond O minus बन जाएगा, because this would have a base HO minus. जो HO minus है वो H plus निकाल के Br minus, I mean CO minus बना दिया. Correct. Then the bromination is done. Br and Br, Br plus, sorry, Br plus OH2 plus, ऐसे था ना, ये इलेक्ट्रोफाइल था. So imagine this attacks here, water चला गया. So we will have this as OH, then C double bond O minus, and Br आ गया. And this is how the group has been, right? यहाँ पे positive charge आया. Got it. Now you see this CO2 will be relieved from its position. So I would have this as OH and Br with minus charge coming on it, plus charge here. It's aromaticity retained. So I'll get this as OH and Br. And after this, anyway we have excess amount of bromination to be done, right? So Br2 H2O करते ही जा रहे हैं. So finally the product which you will get is 2,4,6. So we'll get this as 2,4,6 tribromophenol. Beta clear है? Simran, are you able to get this beta? Okay. Now the last thing in bromination, one more example I'll take. Suppose if you have phenol with SO3H, Here SO3H is there, right? And on this we are heating, on this we are reacting with bromine water, Br2 and H2O. Here also the same thing will happen. So we will get this as OH and Br will come out of it plus SO3 आ जाएगा. Okay. Well, SO3 गैस की तरह नहीं जाता है because पानी है ना. So if it is in water, it would appear to be H2SO4. So the same thing, just like how we have done for COOH, you can do the same thing for SO3H also. The first case what we have done is bromination. Now let us do sulphonation. So what we are doing in sulphonation, we take the phenol and react that with concentrated H2SO4. If the temperature is very low, okay, then it is kinetically controlled product, kinetically favored product. We'll have OH and SO3H. This will be the KCP, kinetically controlled product. But if you go for high temperature, concentrated H2SO4, and it is around 100 degrees centigrade, then you will get this as SO3H, and this will be thermodynamically controlled product. If we get kinetically product here and heat it, we'll get again thermodynamically driven product as well. That's with sulphonation. Next, nitration. So in case of nitration, we will have phenol reacting with cold and dilute HNO3. So in that case, we will get this as OH and NO2. Okay. And other case, you will get it as at para position, OH and NO2. But यहाँ पे H और O में hydrogen bonding रहेगा. That's why this is going to be major. So ortho is going to be major in this case. Case of nitrogen. Okay. So if you see the mechanism here, whenever you have HNO3, ये ध्यान रखना बेटा, HNO3 हमेशा dissociated form में रहेगा. HNO3 is never a stable acid. It will always be in a dissociated form. So if I take dilute HNO3, it will always have some amount of HNO2 present in it already. क्योंकि HNO3 है ना, वो dissociate होके HNO2 में convert होने लगे. And these two will interact with each other, forming NO plus to NO3 minus and H3O plus. That is how this electrophile has been generated. Got it? So this is NO2, no? Sorry, NO2 plus. Yeah. So that's how we got this as NO2 plus. So beta. Now, if we do this with strong base, strong acid, we have taken a dilute condition. If I take this as concentrated H2SO4, sorry, HNO3. So if I take concentrated HNO3, okay, this is a strong oxidizing agent, so it would convert that to quinone. हमने ये पढ़ा है ना, अगर strong oxidizing agent KMNO4, K2Cr2O7, HNO3 इनका सबके साथ रिएक्ट करेंगे तो वो क्विनोन में बदल जाएगा. So you would see 98% will be only quinone. Only 2% will be substituted form. So आपको मिलेगा NO2, NO2 and NO2. This is the way you can get. Okay. I think that point is clear. Right. So if you want to prevent this, and if you want to get more of a, this form, अगर यही मुझे चाहिए, So to prevent that, what we do, to prevent oxidation, first we do sulphonation, OH with concentrated H2SO4. Okay, concentrated के साथ कर रहे हो तो there is a high chance that it would come at all the positions here, so we will get this as SO3H, SO3H, like this. Okay, now then you do the nitration here, HNO3, और आपको पता है HNO3 में NO2 तो रहता ही है, राइट? सो देन HNO3 के साथ सल्फोनेशन में से ये निकल जाएगा ग्रुप और हर जगह NO2 आ जाएगा. Just think about it, COO minus, SO3 minus, they are easily leaving group on benzene. Okay, so जहाँ पे भी SO3 minus है, CO minus है, आप आराम से निकाल सकते हो उस ग्रुप को. निकाल के आप NO2, OH, Br, क्लोरीन, अल्काइल, ये सारे के सारे आप easily replace कर सकते हो. Right. So this is nitration with desulfonation because we are removing sulphonation as well, right? And this molecule which is formed now, this is called picric acid. Okay. In fact, इसका pH इससे पहले मैंने बताया था लगभग 1 है इसका pH. Very strong acid. Is highly explosive also. It appears as yellow color solid. Okay. So this is about picric acid. Clear, beta? Okay. So these are all the reactions which you have. The last set of reactions which we'll do is reduction reactions. What happens if you have oxidation ho gaya abhi? Let us do reduction reaction. This is the last set of reactions of phenols. The first thing what you will see is if you take phenol and react that with zinc and heat, mechanism का कोई जरूरत नहीं है, benzene plus ZnO बन जाएगा. Okay, so imagine this way that Z electrons दे देगा benzene को और oxygen निकाल देगा वहां से. Next, this we have OH here and reacting that with H2 is activated metal complex, activated metal catalyst, high temperature and pressure. If you do that, then you will get it as this. Mostly it is used by Raney nickel. You use Raney nickel, which is activated metal catalyst, then benzene will get reduced. Both rare cases है benzene को reduce करने का. This is one of them. Next, O, alkylation. Okay, on the ortho position we are doing alkylation. So phenol, if I treat that with CH3X and OH minus. So OH minus will pull away that O minus and O minus will make an reaction here. ये हमने पढ़ा है already, Wilkinson synthesis, right? Sorry, Williamson synthesis, ethers formation. Okay. Same way, if you do the reaction with CH2N2, ये भी पढ़ा है हमने, preparation of anisole. O minus अटैक करेगा, आपको मिल जाएगा OCH3. Right? Same way, ये भी पढ़ा है हमने, Me2SO4. Again, you'll get it as anisole, OCH3 plus SO4 2 minus, okay, plus N2 here. Right. This is reaction third, fourth. Suppose if you have reaction, this one, OH, and I take 2 moles ETO minus Na plus of 2 moles, and then react that with EtBr. So we will have this as EtO Et plus PHO minus Na plus NaBr. What does that mean? So when I'm taking two equivalents of this, got it? O minus has attacked here first, got it? And then Br minus has removed, right? So EtO Et aa jayega, okay? And the second mole, oh right, sorry, second mole which I have will connect with phenyl and it will become OET PHOET. ये बन जाएगा. So if you have 2 moles of it, got it? Is that clear, beta? But when it comes to competing, problem क्या है? PHO minus and ETO minus. Okay, the strong nucleophile, if you check out, is always this. Okay, so the major product which will form is still this one only. ये major आएगा and this part will be minor. Okay, ये बहुत कम आएगा. I hope that point is clear. Yeah. Now the fourth reduction reaction which we'll see is O acylation. So phenol, if we react with CH3 C double bond O Cl or acid chlorides or anhydrides. CH3 C double bond O, sorry, CH3 C double bond O, O C double bond O CH3. Acid chlorides or anhydride, if you react in both the cases, you will get that O C double bond O CH3 get connected. Okay, same nucleophilic substitution. ऑक्सीजन का लोन पे जाके कार्बन पे अटैक करेगा, क्लोरीन निकल जाएगा. So we get this. Next one is called Schotten-Baumann reaction. Schotten-Baumann reaction. We take phenol, react that with PH C double bond O Cl. Doing that in the presence of NaOH, we'll get it as O C double bond O pH. This is what we get. Okay. So basically, इसमें product जो form हो रहा है ना NaCl, this Cl minus can again react back and get this reaction in the forward direction. Okay. So if you want to avoid that, react in the presence of, I'll write this like this. And if you want this reaction not to go in the backward direction, along with that, add some pyridine also. And adding pyridine, what would this happen? It will become pyridinium chloride. Okay, H and Cl minus. Okay. Got it. So when you do this, reaction will mostly go in the forward direction. Next, see Gattermann-Koch reaction. Gattermann-Koch reaction. We did this in benzene also. When we did about benzene, the same reaction repeats here also. With benzene or with phenol, the reaction is same. CO plus HCl. When you do this, वहाँ पे हम लोग इसको only benzene रहेगा तो Koch reaction बोलते हैं. With phenol, it is just called as Gattermann-Koch. You have OH and it will give CHO here, ortho and para positions. OH and CHO, ortho and para positions. Okay. So simple steps मैकेनिज्म की सिंपल स्टेप दिखा देता हूँ. So C triple bond O minus है. If you treat that with HCl, it will take H plus and it will form HC triple bond O plus. Carbon highly positive. So in fact, if I write the resonating structure, it is like this, with positive charge on it. Okay. So benzene can, phenol can easily react onto that. So if I take phenol, and then you have C double bond O H, positive charge on it. So this will attack here. It would make this reaction to go as OH, CH double bond O, and H, getting here positive charge. Okay, Cl minus will remove this H plus, retain the aromaticity. So we'll get this as OH and CHO. I hope you got that, right? This was actually supposed to be Koch reaction. Okay, so phenols ke na sare Gatterman has identified. That's why he has always put his names. Okay, so we have only Gatterman reaction also. Only Gatterman reaction. Because this is something which we have not done with benzene. This is done only with phenols. So that is, if we take phenol and react that with HCN, right, cyanic acid, in the presence of HCl and AlCl3, giving H2O and H plus. Again, you will get this as aldehyde. Okay. If you see the mechanism, phenol start with HCl. HC triple bond N. When it reacts with HCl, the lone pair on nitrogen will attack on H plus. That will make it HC triple bond N H positive. इसका resonating form आप check करोगे, so it will be HC double bond NH H positive. So फिर से एक electrophile generate हो गया. That is all what we need. As long as we get electrophile, it will become easy. So we'll get this formation as phenol plus HCH double bond NH with this getting positive charge on it. So if I write in the phenol form with pi bonds, so it will attack here. So we will get phenol with CH double bond NH. CH double bond NH. And then Cl minus, which has come out, will accept this H plus, retain the aromaticity. So aromaticity आ गया यहाँ पर. So ring has become aromatic. You have CH double bond NH. CH double bond NH on hydrolysis, जब भी है ना बेटा, ये ध्यान रख लेना, C double bond N रहेगा. So you hydrolyze it, it would immediately break into C double bond O. So you'll get this as CHO, and that nitrogen will come out as ammonia. Okay. इसका mechanism हम लोग aldehydes में करेंगे, because it has a complete section there. But all you need to remember is C double bond N will always be converted into ammonia. That point is clear, right? So now you see the last thing what we'll do is the test for phenols. We have done test for alcohols, Victor Mayer test. What other tests we can check out for phenols? One, sodium metal test. Sodium metal test. So when you react any phenol with sodium, you know that it will give phenoxide ion plus H2. So that makes it, as you will get H2. We can say effervescence of H2 is a test for hydrogen. Effervescence for effervescence of H2. Effervescence of H2 confirms that there is a phenyl group present on it. Litmus test. Okay. So it will convert blue litmus to red. मतलब ये acidic behave कर रहा है. Is behaving acidic. Next, neutral FeCl3 test. This one is very, very important for us. Okay. So basically, this is a test for enol. This is a test for enol. Any enol is present, there is a definite chance for color change here. So if I take 6 moles of phenol, if I take 6 moles of phenol here, okay, react that with Fe plus 3. Then what do we have is phenol with O, pH 6 with plus 3 minus. ऐसा कॉम्प्लेक्स बन जाएगा. आपको ये नहीं पूछेंगे कॉम्प्लेक्स कैसा दिख रहा है, आपको सिर्फ इतना बताना है कलर क्या चेंज होगा. So it is violet coloration. So whenever you react phenols, then you will get violet colorations. Okay. So next, any form which you have an enol, जिसमें enol ज़्यादा stable है, वो हमेशा देगा ये. Suppose if you have double bond O like this, okay, then its enol will be very, very stable. Same way, if we have double bond O, this will also have high enol content. So any group which has high enol content, they will always give this FeCl3 test. Also gives red or any color. Okay, you'll just ask whether it is colored or not. Any color with FeCl3. Okay, so that is about the FeCl3 test. Bromine water हमने देखा है. With bromine water you will get a white crystalline form. So that is also confirmatory for presence of phenol. With KMnO4 we saw it will decolorizes and solutions become brown because it will form quinone, and quinone are brown colored solutions. And can test, I have told you in alcohols. So any form of alcohol present, it will oxidize. This will also give quinone, and that is also brown color. And lastly, Lieberman nitroso test. याद आ गया बेटा, ग्रीन से रेड से ब्लू, जीआरबी पब्लिकेशंस. ओके, बस ये हो गया आपका फिनॉल्स. होप यू गॉट दिस. सो दीज आर द टेस्ट. सो एक बार गो थ्रू करो, इसमें से जहाँ पे भी मैंने स्टार मार्क किया हुआ है, दोज आर इम्पोर्टेंट एरियाज. उस पर थोड़ा 2-3 बार ज्यादा प्रैक्टिस करना चाहिए आपको, क्योंकि उस पर क्वेश्चन ज्यादा रहेंगे. ओके, like Riemer Tiemann, this is one very, very important reaction. Right? Other than that, 1 second.